Okay, let's unpack this. We're doing a deep dive today into a really deep, almost existential question about, human motivation and happiness.
Hmm.
What is the fundamental difference between that explosive, sometimes kind of destabilizing joy we get from our senses,
All right.
like biting into the perfect piece of chocolate or that rush of winning a big prize,
Mm.
and the deep, pervasive, really ecstatic pleasure that can be achieved through advanced meditation?
And we're not just talking about feeling a bit more relaxed here.
No, not at all. We are talking about profound, internally generated bliss.
That's right. And we've been handed this stack of really cutting-edge research that compares brain scans of people experiencing these intense meditative states known in the contemplative traditions as jhanas.
Like the jhanas.
And it compares those scans with the standard reward circuitry, the mesocortical limbic system that drives our everyday, consumption and survival behavior.
So our mission really is to dissect the neurobiology behind these two types of pleasure.
Exactly. Is meditative bliss just a supercharged hit of the same old stuff, or is it fundamentally structurally different? That's the core question.
And crucially, the practical application here is just massive. I mean, if this internal source of pleasure, the sukha and piti, is structurally different,
And then it could be a powerful tool.
an endogenous tool, right? One for restructuring the deeply rooted architecture of craving and addiction, which so often defines itself as that painful, relentless pursuit of some external reward.
We are looking for the brain's internal override switch.
And we should be clear about the sources. We're relying on some really high-level data.
We are whole brain functional connectivity models, ultra high resolution 7 Tesla fMRI data from practitioners achieving these advanced concentrative absorption states, AKMJ states.
And also those foundational pharmacological studies, the ones that clearly distinguish the components of external reward.
The ones that separate what we mean when we say we like something versus when we truly want it.
That distinction.
That distinction is the bedrock. It's everything for understanding why we crave.
Okay, let's start there. Let's start with the familiar. When we talk about sensory pleasure foods, sex, money, social validation,
All of it.
we're activating the brain's evolutionary imperative, the mesocortical limbic reward system. This is the circuit that links desire to action, that tells us what's valuable out in the world and motivates us to go get it.
And this circuit is widespread and incredibly ancient, biologically speaking. It's what allowed our ancestors to survive by recognizing, say, high-calorie food or a chance to reproduce.
What are the core components?
Well, the deep brain structures are key. You've got the ventral tegmental area, or VTA, which acts like the starting pistol.
And that fires onto the nucleus accumbens.
Exactly, the NERAC, which is part of the ventral striatum. It's the hub, the nexus of reward valuation. But it's not working in a vacuum. It integrates with higher-level areas like the orbifrontal cortex for value judgment and the insula for integrating the body's reaction to it all.
And for decades, popular science and even some early neuroscience really simplified this. It was all dopamine is the pleasure chemical.
A total misconception.
But the real insight from the last 20 years of effective neuroscience has been the complete disentanglement of pleasure from drive. We have to make that crucial distinction you mentioned, liking versus wanting.
This distinction is paramount. It changes everything about how we look at addiction and craving. So liking is the objective or subjective experience of pleasure itself, the actual hedonic impact.
The momentary rush, the immediate satisfaction.
That's it. And in the lab, we can track this reliably even in animals. We can observe their effective facial expressions, these involuntary signs of pure hedonic response, like rodent licking its lips when it tastes something sweet.
And the chemical driver for that pure sensory liking. It's not dopamine.
It is not. It relies heavily on the opioidergic system, endogenous opioids, like endorphins. And this pleasure isn't just spread diffusely across the brain, it's generated in very small, localized structures we call hedonic hotspots.
Hedonic hotspots. And you stressed their size earlier. These are tiny little regions that have a huge, disproportionate responsibility for feeling good.
They're microscopically small, yes. In rodents, these critical areas found in the nodding shell, the ventral pallidum, and the brainstem are only about a cubic millimeter in volume.
A cubic millimeter?
Yeah. If you scale that to human brain size, we might be talking about cubic centimeter hotspots that are the core generators of raw pleasure.
And the evidence for this is strong.
Very strong. When researchers give subjects opioid antagonists, like naltrexone, which block opioid function,
The pleasure goes down.
right, subjects report a significant drop in the intensity of pleasure they feel from a reward, and objectively, their facial reactions, the ones associated with greater liking, They just diminish. Opioids are the key players in the subjective feel of pleasure.
Okay, so opioids give us the hedonic impact, the liking. But then what about dopamine? This is where the story shifts dramatically, from pleasure to pure drive
Yeah.
to wanting.
Wanting is fundamentally incentive salience. It is the raw motivation. It's the drive that makes external things attractive, attention-grabbing, and able to trigger urges, often before we're even consciously aware of it.
And this is mediated by those dopamine projections.
Exactly. The mesolimbic dopamine projections, which fire from the VTA to the NAC, we now know dopamine does not cause sensory pleasure or liking itself. If you block dopamine, you reduce the motivation to seek the reward, but the hedonic reaction, the liking, is still there if the reward is just given to you.
So dopamine is the engine of motivation. It provides that motivational magnet.
That's the perfect term for it. It promotes approach behavior.
Let me push back on that for a second. If dopamine doesn't cause pleasure, what's its evolutionary purpose in this loop?
Yeah.
I mean, why would the brain separate the drive from the satisfaction? It just seems inefficient.
That's a brilliant question, and it actually speaks to the efficiency of survival. Dopamine isn't a pleasure signal, it's a prediction error signal.
A prediction error signal.
Yes. It fires loudest when the reward is better than you expected, or when the cue that predicts the reward appears. Its evolutionary benefit is all about learning and directed action.
Ah, I see.
By separating wanting from liking, the system makes sure that we stay motivated to search for new resources or use learned pathways, even after the initial liking has faded. It's an engine designed to keep us moving and adapting, not just to make us feel good.
But this inherent separation, it creates the perfect environment for pathology, doesn't it? Especially for addiction, which is what we're focused on here. If drive goes into overdrive, independent of actual enjoyment, that's a catastrophe.
That is precisely the addiction tipping point, and it's explained by the incentive sensitization theory.
Right.
This theory suggests that through repeated exposure to addictive substances or even just high-intensity cues, the mesolimbic dopamine system becomes hyperreactive. It becomes sensitized.
And this causes that excessive cue-triggered wanting.
An overwhelming wanting to take the substance. And this sensitivity is often enduring. It can persist long after withdrawal and, critically, long after the person has stopped actually liking the drug.
So someone can be actively trying to quit, they can hate the consequences, they experience almost no pleasure from the substance anymore, yet they still feel this overwhelming, almost magnetic pull toward it.
Exactly. It creates a profound psychological dissonance. The cognitive self, the reflective part that truly wants to stop, is just overwhelmed by this hyperreactive dopaminergic wanting system.
And this is where researchers bring in that analogy of the mythological figure Tantalus.
The Tantalus analogy is so powerful here.
It really is.
It perfectly captures the irrationality and the suffering. Tantalus, eternally tortured, stands in a pool of water that recedes when he tries to drink.
And there's fruit that moves just out of reach when he tries to eat.
It is a painful desire that persists even when the reward is not cognitively wanted or even attainable. So in addiction, this means the drive system leads to a want for something that the conscious cognitive self genuinely wants to avoid. The mesolimbic wanting system has become separated, sensitized, and hyperreactive. It leads to this maladaptive pursuit.
We even see echoes of this in animal models, right? You mentioned sign trackers before.
Yes. In experiments where a lever predicts a food reward, most rats are goal trackers. They focus on the food port. But a significant minority become sign trackers. They totally ignore the food, and instead they avidly engage with the lever itself.
They chew.
They try to chew it. They interact with the cue that predicts the reward, not the reward goal itself. The cue has become the motivational magnet, proving the strength of cue-triggered wanting over the actual hedonic liking. And that's the brain pathology we're trying to solve.
Okay, so we have a clear, externally focused, and potentially pathological system. Opioids for the fleeting joy, the liking, and dopamine for the relentless, compulsive drive, the wanting. Now, the critical question, how does the brain generate profound, stable bliss without any external lever, without any sweet taste, or any monetary cue? So we're moving into these advanced contemplative absorption states, the ACAM-J states, and the descriptions here are, they're extraordinary.
They really are.
Practitioners describe intense, ecstatic, stable experiences. They call them piti, which is this rapture or euphoric physical pleasure, and sukha, which is more like happiness or a deep, tranquil contentment.
And the traditions define this as a wholesome or noble pleasure because, unlike sensory pleasure, it promotes his profound mental stability and focus.
Okay, so the first research objective was simple, I imagine. Is this noble pleasure a totally new circuit, or are meditators just, hacking their existing reward hardware through introspection?
Right. And during the very first stage, Jhana 1, the evidence suggests they're using the same foundational hardware. But, and this is the key, it is volitionally activated.
So walk us through the neuroimaging of that first jhana. What does it reveal about that initial rush?
Okay, so the first jhana, J1, is phenomenologically defined by intense physical rapture, piti, and this really strong euphoric pleasure. When researchers mapped this with fMRI, the state is strongly associated with activation in the nucleus accumbens, the NANAC.
Our core hedonic
The
hotspot.
very same one. And alongside this NANAC surge, there's increased sympathetic arousal, the fight-or-flight response, but here it's experienced as a pleasurable, powerful energy surge. Some call it muscle turgor.
So this is groundbreaking. It suggests the brain's traditional reward system can be activated on command, bypassing the VTA's usual need for an external, surprising reward cue.
It's completely volitional.
But wait a second. If the deepest meditative bliss, at least initially, uses the same ENIAC hardware that processes the rush from cocaine or winning a jackpot, doesn't that inherently make it susceptible to the same kind of addictive wanting? Why is it considered wholesome if it relies on the reward circuit?
That is the essential point of friction. And the sources address it by looking at the input mechanism. The pleasure itself is the same flavor of hedonic liking, rooted in endogenous opioids. However, in jhana 1, the NELIAC is activated not by an external, unpredictable dopamine surge,
Right.
but by intense, self-directed cognitive control. What the traditions call vitakka, directed attention, and vikara, sustained attention.
So the purpose is completely different. It's not to get an external goal, but to stabilize your internal focus.
Precisely. The pleasure becomes a tool for stability, not a reward for an external action. It stabilizes the mind and prevents distraction. That's the definition of wholesome in this context.
So this initial phase isn't passive relaxation at all. It's intense mental work that generates its own internal positive feedback loop.
Exactly. You are using high-level cognitive effort to lock on to an object of meditation, and the byproduct of that intense, sustained focus is the activation of the bliss circuit. The attention factors themselves are driving the reward.
But that feeling, it can't stay at that intense physical rapture level. It has to refine itself, or it risks becoming just another distraction.
It absolutely must refine. The intense physical euphoria of piti in J1 is, by its nature, unstable. It's like standing right next to a powerful waterfall. It's ecstatic, sure, but the sheer force is distracting.
So as the practice deepens, especially by the time a meditator reaches the third jhana, J3, that intense physical rapture fades away.
It's replaced by a much calmer, deeper, pervasive sense of tranquil contentment, of sukha.
What's happening neurochemically to make that transition, to go from the rushing waterfall to the placid lake?
The neural signature changes dramatically. We see the Naker-Act signal is actually reduced compared to the intense activation in J1, so a lower volume of hedonic rush. And crucially, the nervous system shifts from sympathetic arousal to profound parasympathetic dominance.
The rest and digest mode.
The rest and digest mode. This is a physiological signature of deep internal regulation.
And what are the key chemical players that are enabling this deep stability?
Well, the stability is supported by neurochemicals like acetylcholine or ERT in the frontal lobes. ERT is known to enhance sustained attention and mental clarity, but without the agitated nature of dopamine.
And you can see this in the body.
Oh, yes. You see clear physiological markers, significantly decreased respiration rate, sometimes dropping by half, a profound slowing of heart rate, reduced blood pressure. J3 is a masterclass in internal self-regulated stability.
And the sources suggest this isn't just a transient state you get during meditation.
Mm.
The long-term practice actually rewires the practitioner's emotional set point.
That's one of the most exciting implications for treating emotional dysregulation. Long-term absorption meditators appear to exhibit a permanent shift in their neurochemical baseline, a shift toward greater contentment.
And you can measure this.
Yes, it's evidenced by measurably higher levels of serotonin breakdown products, specifically 5-HIAA, detected even before they start a formal meditation session.
And serotonin is the brain's primary mood modulator.
It modulates mood, happiness, social behavior. These consistently elevated breakdown products suggest a chronic baseline activity that supports emotional resilience and deep contentment. sukha. They're literally living from a higher baseline of emotional equilibrium.
This research really positions the brain not as a victim of its circumstances, but as a factory capable of producing its own optimal emotional state.
Absolutely. And if we look outside the contemplative tradition for a moment, the research on the anterior insular cortex, the AIC, it provides this shocking clinical confirmation of this volitional bliss potential.
The AIC is key for the sentient self, right? It's involved in interoception, processing our internal bodily feelings.
It's central to how we feel our own consciousness, and there's this extraordinary case study involving electrical stimulation of the AIC in a patient who had no prior history of mystical or ecstatic states.
None at all.
None. Researchers applied electrical stimulation to the dorsal AIC, and this repeatedly produced an intense, blissful sensation of mental clarity and euphoria.
What did the patient say?
The patient described profound existential insight, reporting things like, everything seems simplified, feeling liberated, that their consciousness has suddenly enlarged. They even spoke of looking at infinity, feeling they no longer have any limits, as if everything was connected.
Wow. That's essentially generating a peak experience, a hyper-reality, or even a mystical state using only localized electrical input to a specific internal brain structure.
It confirms that the machinery for generating these states of profound clarity and boundless insight is resident within the brain itself, and the AIC plays a primary initiating role. This volitional access, whether through deep contemplative practice or direct stimulation, demonstrates that the brain contains a powerful endogenous mechanism for generating stability and high-quality pleasure, entirely independent of the pursuit of external reward.
Okay, so if meditation can produce better pleasure, the next question has to be, how does this internal bliss take on and dismantle the relentless machine of external craving? We've established that craving is this relentless, often painful wanting, driven by a sensitized dopamine system. But why does that loop feel so inescapable? It feels like it hijacks our very sense of self.
It does, and that inescapable feeling is rooted in the activity of the default mode network, or DMN, specifically its main hub, the posterior cingulate cortex, or PCC.
The DMN is what the brain does when it's not focused on a task. Mind-wandering self-narrative.
Exactly. It generates our self-story, it allows for future planning, and it's strongly linked to self-referential thinking. We often describe the PCC as the narrative generation factory.
That's a great way to put it.
Well, the PCC is hypothesized to represent the cognitive process of being attached to or caught up in one's experience. If you're ruminating about a past mistake, you are caught up in that self-referential negative emotion. If you're feeling a strong drug urge, you're caught up in the craving. The PCC is the mechanism of cognitive entanglement.
So what happens to this entanglement mechanism when someone practices focused meditation?
Focused attention practices, like focusing on the breath, are profoundly effective at suppressing this activity. fMRI studies show a significant decrease in PCC activity during meditation in experienced practitioners.
So present-centered attention actively reduces the brain's mechanism for getting caught up.
It's a top-down control mechanism, essentially. The practice cultivates a cognitive skill that allows the prefrontal cortex, your executive function, to suppress the DMN's tendency to get entangled.
And this learning is effective.
So effective that in some studies using real-time fMRI neurofeedback, meditators who were explicitly told to increase their PCC activity to get caught up or ruminate, they actually found it difficult to sustain that activation.
Because their training had already habituated the brain to disengage that circuit.
They've structurally reduced the brain's ability to become entangled.
That's a powerful defense against craving. But the deepest states of meditation go beyond just reducing activity. They seem to restructure the entire dynamic architecture of the brain. This is where we get into that highly technical but profoundly important concept of near-critical dynamics.
This is the most complex yet potentially transformative finding. In the deepest absorption states, jhana 4 and the formless states, which we can call minimal phenomenal experience, or MPE, the brain's dynamics undergo this radical reorganization.
And this was measured with whole brain models and 7 Tesla fMRI.
Yes. We move from asking where the activity is to asking how the whole system is organized.
And what does that organization look like normally, just in the resting state?
Normally, the brain's resting state networks, the RSNs, are highly heterogeneous. They're distinct. They operate in different dynamic regimes. Some are noise-driven. Some are highly oscillatory. There's a whole dynamical gradient.
So networks like the DMN and the visual network are typically stable.
Very stable, far from what's called a bifurcation point, which is a mathematical tipping point between one stable state and another. They're really entrenched in their characteristic dynamics. They're stable in their specialization.
Okay, but in MPE, this changes.
Dramatically. The research shows a phenomenon called the collapse of heterogeneity. This dynamic gradient just collapses. The networks that were previously entrenched and far from that tipping point, including the very DMN that fuels self-referential craving, begin to converge uniformly toward near-critical dynamics.
That sounds incredibly complex. Can you give us an analogy? What does near critical dynamics actually mean for you or me?
Okay, think of water. Normally, water is stable as a liquid. That's its heterogeneity. To turn it into ice or steam a phase transition, you have to push it to a critical point.
Okay.
Near critical dynamics is like maintaining water at exactly 32 degrees Fahrenheit or 0 degrees Celsius. The system is exquisitely sensitive. The smallest fluctuation can instantly change its phase. When the brain operates near criticality, all its components are uniformly poised at that tipping point.
So it's maximally sensitive to new input.
And minimally constrained by its previous organizational attractors. So instead of being entrenched in specialized habitual pathways like a craving loop, the brain becomes globally structurally flexible.
A true blank canvas.
That is the interpretation. This convergence results in an alternative optimal brain state characterized by generalized flexibility. The system is ready to adapt, to learn, to restructure. This maximal openness allows the brain to reorganize its entire dynamical repertoire, including those deeply rooted attractors related to maladaptive pursuit.
But is it a functional state? I mean, if the brain is on the verge of collapsing, can it still operate?
It is functional, but in a profoundly reduced state. That's why it's called minimal phenomenal experience. The significance is less about what you do during MPE and more about the potential for deep systemic reorganization when you emerge.
And emerging from these states is associated with radical shifts in perception.
And profound emotional insights, and the ability to reset deeply rooted patterns, including those of incentive salience. It provides a mechanistic, a physical explanation for the kind of transformation described by advanced practitioners.
And the final documented state takes this reorganization to the absolute edge, the cessation of consciousness, Nirodha Samapatti.
In Nirodha Samapatti, consciousness is suspended entirely. The high-field 7T fMRI shows the brain doesn't just cease activity in some messy way. It undergoes a radical, organized reorganization. There's global quieting communication drops significantly, especially between the brainstem, our alerting system, and the higher cortical networks.
But it gets more organized.
In a way,
Yeah.
the organization becomes more polarized, suggesting that while the narrative conscious self shuts down, the foundational alertness mechanisms might actually sharpen or reset. And there's a significant drop in basic energy patterns, consistent with a total yet temporary mental shutdown of conscious processing, a profound volitional act that resets the entire system's operational baseline.
Okay, let's bring this all together. We have established that sensory craving is an overwhelming, painful wanting signal driven by dopamine and incentive salience.
Right. The Tantalus effect.
And we also know that meditation can generate high-quality internal liking sukha, volitionally activating those opioid and hedonic circuits, while simultaneously providing both top-down control
By reducing the PCC activity.
and a total systemic reboot through that criticality reset.
Yeah.
This is our model for overcoming the Tantalus effect.
And this directly addresses the core neurobiological challenge of addiction, which is hedonic dysregulation.
Hedonic dysregulation.
Yes. In addiction, the brain experiences what's called a downward shift in the salience of natural reward relative to drug reward. Your morning coffee, your favorite meal, a conversation with a loved one, they all start to taste dull compared to the sensitized drive for the drug.
And meditation attacks this problem directly.
It does. It cultivates new, high-quality, non-pharmacological reward, while at the same time dampening the very mechanism that drives that external pursuit.
And we don't have to rely purely on these advanced absorption states to see the clinical benefit. This principle is being actively applied in structured therapeutic models.
Absolutely. The leading example is mindfulness-oriented recovery enhancement, or MORE. This clinical intervention is specifically designed to address this dysregulation and restructure reward processing by integrating several key psychological components.
The name suggests it's more than just sitting quietly and breathing. What are the key elements of MORE?
MORE integrates traditional focused attention mindfulness, observing the present moment without judgment, with two other critical active elements, reappraisal and savoring strategies.
And the clinical goal is proactive.
It is. It's to restructure those reward processes and facilitate the attribution of semantic and episodic meaning to experiences, reducing that downward shift in natural reward salience.
Okay, let's start with savoring. If craving is overwhelming wanting, how does savoring restructure reward?
Savoring is the intentional process of amplifying and prolonging the liking component of natural, non-addictive rewards. For example, if you eat a piece of fruit, instead of just rushing through it, savoring involves paying intense, sustained attention to the texture, the aroma, the flavor,
The bodily sensation of pleasure.
and sustaining that positive experience long past the immediate intake. This practice is hypothesized to re-engage and strengthen the endogenous opioid system and those hedonic hotspots, the liking circuitry, in response to healthy, natural stimuli.
So we're volitionally retraining the opioid system to find natural rewards intensely pleasurable again.
Precisely. We are building new reward pathways by consciously increasing the hedonic impact of everyday life. This counteracts that hedonic gap created by addiction, making the natural world more rewarding relative to the artificially high salience of the drug.
Okay, and the second key component, reappraisal. How does that link to the neural architecture we just discussed?
Reappraisal is a powerful cognitive technique where an individual changes the way they think about an emotional event or stimulus. It's about restructuring the emotional meaning of a situation.
So when you apply that to craving,
It allows the individual to recognize the urge not as an imperative command for action, but as a temporary objective physical sensation, a transient thought pattern.
that sounds like it would require the suppression of the DMN, that entanglement loop we talked about.
It does. The cognitive control cultivated by mindfulness, that ability to reduce PCC activity and step outside the caught-up state, is what functionally enables successful reappraisal. If you can distance yourself from the urge, you can then attribute a new, less compulsive meaning to it.
So instead of, I must have that drug,
The reappraisal becomes something like, that is my sensitized brain creating a familiar, painful, wanting signal, which I'm choosing to value as a reminder of my recovery goals.
so this moves beyond simple non-judgmental observation and into actively changing one's values and goals.
Absolutely. It leverages a crucial human attribute, the ability to evaluate our own desires. While some traditional mindfulness approaches might suggest suppressing all evaluation, Moore acknowledges that restructuring is a cognitive act. By achieving semantic and episodic meaning, connecting the choice to a larger life narrative, we engage higher cortical functions to override that sensitized incentive salient system. We use the flexible, aware mind to define a new value system.
So the overall solution involves both generating internal pleasure and simultaneously dismantling the compulsive internal structure that drives external seeking.
That is the summary of the neural pathway in action. 1. Endogenous reward activation. We use jhana practice, or clinically savoring strategies, to volitionally access the endogenous reward circuits to create stable, wholesome pleasure sukha. This directly addresses the hedonic deficit.
2. Top-down craving reduction.
Right. We engage the executive control of the prefrontal cortex to reduce DMN and PCC activity, which prevents the brain from getting caught up in the ruminative, self-referential thought that fuels compulsive craving.
And 3. Systemic reset.
Through deep states, or even just the generalized flexibility gained through sustained practice, the brain achieves near-critical dynamics. This allows a potential reset of those deeply rooted attractors related to maladaptive incentive salience.
Ultimately, this framework suggests that happiness and stability are defined by the balance between these two forces, liking and wanting.
That is the conclusion. Happiness may be defined as maximizing liking, the hedonic pleasure and contentment, without the disruptive, compulsive wanting that spirals into unhappiness and addiction. Too much sensitized wanting pushes us toward Tantalus. The cultivation of sukha allows us to generate contentment from within, facilitating a healthier, less driven engagement with the external world.
So what does this all mean for the learner, for you listening today?
Yeah.
We've seen that sensory pleasure forces you to respond to the external world with a powerful, potentially catastrophic drive for reward, the compulsive craving of Tantalus. Meditative pleasure, however, is about generating joy and stability entirely internally. It's utilizing the same reward hardware, but effectively overriding the external input mechanism and, in the deepest sense, restructuring the brain's entire operating system.
I think the greatest insight here is twofold. First, the human brain possesses this remarkable endogenous capacity for self-generated stable reward. And second, the concept of maximal openness and generalized flexibility achieved in deep meditative absorption.
That state of near-critical dynamics.
It's not just a philosophical concept. It is a demonstrable physiological mechanism for deep systemic transformation. The brain literally possesses a blank canvas mode capable of wiping out entrenched maladaptive patterns.
This research moves meditation so far beyond being a tool for simple relaxation. It positions it as a fundamental tool for volitional neuroplasticity, capable of redefining our very relationship to pleasure, pain, and motivation.
And that leads us to our final provocative thought for you to consider. If the brain can be volitionally driven to a state of such generalized structural flexibility, a true blank canvas state, does this suggest that the limits of human experience, including the compulsion of craving and the ingrained structure of our self-narrative, are ultimately determined not by external stimuli or genetics or circumstance, but by the dynamic organization of our own consciousness? The ability to achieve self-mastery might be rooted in the ability to intentionally push the brain to a critical, transformative edge.